Hi, it's Jesse Wagner. Today I'd like to share with you one of my favorite icebreaker activities for my 8th grade physical science students, a boat building challenge. It's a classic STEM activity in which students design boats to hold as much weight as possible. This year I tried a 3-phase approach. First, my students built boats out of aluminum foil. Then they redesigned their boats, but they were allowed to reinforce them with things like straws and craft sticks. And finally, they used Tinkercad to 3D print boats. For many of my students, this was their first time ever 3D printing something, and this video is the first of a 10-part series meant to showcase some of the activities we used our 3D printer grant money for. So if you're a science enthusiast or an educator looking for ideas, I'd like to welcome you aboard as we set sail on this boat building challenge. Phase 1 of this challenge began with each group receiving a 1 square foot sheet of aluminum foil. I wouldn't skimp on the quality here. I found that cheaper rolls tend to rip very easily in the folding process. I usually cut out a few extra in case one does end up ripping. These rolls have 150 square feet, so we'll have more than half left over. I try not to give students any hints about how to build their boats. Some groups go for deep hull designs, but aluminum foil doesn't have much rigidity. The water pressure usually causes these boats to collapse inward. Others go for a canoe-like shape, which offers slightly more support, but they can often face the same issues. The best designs I've seen are flat barge-like boats. Since my students haven't covered the buoyant force yet, I explain it in the debrief by comparing it to wearing snowshoes. You spread out your weight to avoid sinking. These flat designs really hold up, and it's not uncommon for students to load hundreds of pennies into them. In fact, I've had groups get in over 350 pennies before their boats eventually sank. With 6 lab groups, I have to keep about $20 of change on hand to avoid from running out of pennies. Students might want to turn this into a competitive challenge, and if you decide to go that route, I have a few things you need to consider. First, not all pennies are the same weight. Pennies minted before 1982 are mostly copper, and are heavier than newer pennies which are mostly zinc. Here a stack of 10 copper pennies is shown to have quite a bit more mass than 10 of the newer zinc pennies. To keep things fair, make sure that the pennies are from the same time range, either before or after 1982. Second, the pennies are going to get wet as the boats sink. If your first class uses dry pennies, they're going to have a clear advantage over later classes. So to level the playing field, I pre-soak all the pennies in water. Lastly, let's be honest, coins are gross. It's a good idea to sterilize them before handing them out. For phase 2 of the activity, I encourage students with successful boats to build upon their designs, reinforcing them with materials like straws and craft sticks. Groups whose boats did not perform as well are encouraged to redesign their models. Most are probably going to copy the successful designs, while others might try to tweak their original ideas to see if they can make them work better. I never tell students how to design their boats. This is about figuring out things through trial and error. There is one little trick, though, that I do like to share: capping the ends of straws with hot glue to create pontoons, which can add a bit more buoyancy. This part of the activity is especially fun because students usually see their boat's cargo capacity increase dramatically, so long as they don't add too much weight while reinforcing them. For the third and final phase, students use Tinkercad to design their boats. For most of my students, this was their first time ever using it. This required a bit of a tutorial on how to do things like size objects, group and align them, and cut holes in things. There's many good tutorials out there on how to do this, but I decided the best way was to let them figure it out on their own by giving them a list of things to design. I went around the room and worked with each group on how to carry out each of the tasks. Once students had a good enough understanding of how Tinkercad worked, it was time to start designing the boats. Because it was their first time using Tinkercad, most of the designs were simple and consisted of only a few shapes: a triangle and a rectangle, 2 triangles and a rectangle, or even just 1 rectangle. One of the most effective simple designs involved 2 cylinders and a rectangle, which gave the boat a rounded hull. That helped with the locomotion part of the test by making it a bit sleeker. I gave students a maximum dimension and showed them how to get a ballpark calculation on the theoretical mass that their boat should be able to hold, assuming the density of water is 1 gram per milliliter. Of course, this isn't exactly the case, and these calculations do not account for things like surface tension. Also, depending on the shape of the hull, the volume calculations can be quite complex. After printing the boats, it was time to test. The first challenge was the cargo capacity, just as in phase 1 and 2. There were some issues we encountered. First, some students designed boats that were way smaller than I expected, and so the washers I had planned to use would not fit in their boats. For other boats, the washers fit fine, but they were very unstable. I think in the future I'm going to have students simply add pennies like they did in the earlier phases. The next test was a stormy sea. This is where the boats that had curved hulls excelled, as they had a better time breaking through the waves. Smaller boats did not fare well at all. Finally, we tested locomotion by placing a sail onto the boats. Each group was given a 3D printed mast mount that I designed and hot glued it into their boat. I let students choose the location, but encouraged them to place it near the center. For the locomotion test, I had to improvise, and so we used a sled that was wide enough for the boats to sail. My hope was to be able to race the boats, but the fan was not big enough, and also the way the blades spin gives one side a significant advantage over the other. Next year, I'd like to try this using gutters instead and have identical fans behind each to keep it fair. Overall, I'm very impressed with what the students were able to come up with as they embarked on their first 3D printing activity. Thanks for sticking around. In the next video, we'll see how my 8th grade science students use their newly acquired Tinkercad skills to design and 3D print models of atoms for an activity on atomic bonding. Hope you enjoyed the ride, and don't forget to like and subscribe.